Welcome to the deep dive. Today, we're going deep on a topic that's probably pretty familiar to a lot of you computer science folks. Migrating those big monolithic applications to microservices. So you think there's like SciOsh.
Sure.
You've got this huge software program, kind of like a giant cruise ship, you know? But the company, they need to be a lot more agile, especially with everything moving to the cloud these days, right? And that's where those microservices come in. Think of it like a fleet of smaller boats, all nimble, and each one has its own specific purpose. Now, source material for this deep dive is a PhD thesis, which, might sound a little intimidating at first, but I promise I'm here to break it down, make it all digestible, and, dare I say, even fascinating. By the end of this, you'll have a solid grasp on the problems and solutions, the ins and outs, of moving from those clunky monoliths to those sleek microservices.
Yeah, and you know what's really interesting about this thesis is it doesn't just, throw out theoretical concepts. It actually digs into these real-world challenges that companies are facing. I mean, look at a company like Burger Leroy, for example. They're a software company, and they manage a ton of applications. And they're realizing that these giant monolithic programs, they just don't cut it anymore. They worked in the past, but now they're a bottleneck. They're tough to scale. They're slow to update. And it's super risky to change anything. Imagine like trying to add a whole new deck to that cruise ship while it's still out at sea.
Oh, yeah, that's
Yep.
not a good situation. And not to mention, you try and make even like a small change to one part of the application.
Yep.
uh, who knows what's going to happen somewhere else? It's like a domino effect.
So the thesis, it breaks down this migration process into two main challenges. The first is identification. So that's figuring out how to actually split up that monolith into logical microservices. Like, where do you make the cuts on the cruise ship right to create all those smaller boats? And then comes the second challenge, materialization, which is actually rewriting the code to transform those, chunks that you identified into fully functional and independent microservices. So it's not just enough to draw lines on a blueprint. You got to actually build those new boats from scratch.
Right, and that's where this thesis gets really insightful. It points out that a lot of these migration approaches, they miss a really crucial element, and that's the internal structure that often already exists within these monolithic applications. They might have different modules or layers,
Right.
almost like decks and compartments on a ship.
Oh, okay, I see.
So what the thesis proposes, using these existing technical layers as a guide for identifying those potential microservices, like take the JPET Store application, for example. It's got a presentation layer, a business logic layer, and a data access layer. By aligning your microservices with these existing layers, you can create much more cohesive and independent units.
Yeah, that makes sense. So it's like you're using the ship's existing blueprint as a guide instead of trying to just, start from scratch. But the thesis also mentions these things called wrong cuts. What are wrong cuts?
Well, that wrong cut is when you basically decompose the application in a way that ignores these natural boundaries. It's like cutting through the cruise ship horizontally, slicing through all the different decks. Instead of separating those functional compartments, you just end up with microservices that are still tightly coupled and really hard to manage independently. It's like, imagine if you try to separate the engine room from the rest of the ship, but you accidentally cut through the fuel lines. It would be a disaster.
Yeah, you definitely have a mess on your hands. So it sounds like understanding that internal architecture is really crucial for avoiding those wrong cuts and creating microservices that are truly independent and efficient.
Exactly. And once you've identified those potential microservices,
Yeah.
you've got to actually build them. And that's the materialization challenge. This is where it gets a little more technical, but stick with me, because this is where the rubber meets the road.
All right, I'm ready to get my hands dirty. So what are some of the things that developers really need to think about when they're transforming those chunks of code into fully functioning microservices?
So the thesis dives deep into this whole process. It outlines these various object-oriented dependencies that need to be addressed. I mean, think about it. You're taking these classes that used to live together, all cozy in that monolith, and now they have to talk to each other across different services. And that requires some clever engineering. We're talking about things like method invocations. So how one class calls a function in another class. Or attribute access, how one class accesses data stored in another class. Even things like inheritance relationships and exception handling, these all need to be carefully considered.
So it's not just about like copying and pasting code.
Yeah.
You're really re-architecting all those relationships and those dependencies so that the new microservices can actually work as these independent units.
Exactly. And the thesis actually offers some specific solutions for addressing these dependencies, which we can dig into a little bit later. But for now, I think it's time we shift gears. and talk about a really key innovation that this thesis brings, this model-driven approach to migration.
Ooh, okay. Model-driven approach. What does that even mean? Is that like having a super detailed blueprint for building these microservices?
You could say that, yeah. See, the thesis argues that relying only on code-level transformations can get really messy, especially when you're dealing with large applications that are written in like a bunch of different programming languages. So instead, it proposes using this thing called model-driven engineering, or MDE, to create a much more adaptable and reusable migration process. Imagine you're building a house. You wouldn't just start laying bricks and hope for the best right. You'd have a blueprint first. And that blueprint, that's your model. And in MBE, you use these models to represent your entire software system.
Oh, I see. So instead of working directly with the code, we're creating this abstract representation of the application, kind of like a blueprint of that cruise ship, and capturing all of its important components and relationships.
Right. And then you take your desired microservice architecture and you basically incorporate it into this model. You're essentially drawing those cuts on the blueprint. Then you transform the model to represent this new structure. And finally, you generate the actual code for those microservices from this transform model. It's like having a set of instructions that tell you exactly how to build each of those smaller boats.
Okay, that sounds like a much more organized and systematic approach than just hacking away at the code. So what are some of the benefits of using this MDE for microservice migration?
Well, one big advantage is reusability. Because you're working with models, you can apply this approach to applications that are written in tons of different languages. You know those blueprints. They work for building sailboats, speedboats, cargo ships, whatever kind of microservice architecture you need. And it also gives you more flexibility in customizing the final output. You can choose specific platforms and frameworks for your microservices, like picking different engines or navigation systems for those boats.
Wow, this is really fascinating. So we've gone from identifying those potential microservices based on the internal architecture to actually materializing them. And now to this super smart model-driven approach. I feel like we've laid down a really solid foundation here for understanding the key elements of this thesis. So where do we go from here?
Well, now that we've covered the theoretical stuff, let's look at a real-world example. The thesis actually applies this MDE approach to a real license management system called Homage. And this case study, it gives us a concrete look at how all these concepts actually play out in practice and the kind of results they can achieve.
Awesome. I'm always up for a good real-world example. So let's see how those microservices fare out in the open water.
So Homage, this license management system, it was actually developed by Berger-Levrault over a decade ago. And it's a classic example of a monolithic application, built to handle all these software licenses.
So it's like they had this well-established cruise line with one massive ship that was handling all their operations. Might have worked great in the past, but now they want to offer more specialized cruises, adapt to new destinations, be more responsive to all the changes in the market.
Exactly. And the thesis actually goes into quite a bit of detail about Homage's architecture. It's built on this three-tier model, much like the JPET store application we talked about earlier. You've got the web client for the user interface, the server-side application that handles all the business logic, and the database to store all the information.
Okay, so it's that server-side application, that big monolith. That's the focus here. That's where all the action is. But it's also where those limitations of this architecture really start to show up.
Oh, absolutely. The thesis points out that Homage's server-side application had something like 364 classes and over 37,000 lines of code. Trying to make changes or add new features to this code base is like trying to renovate that massive cruise ship. While it's still sailing the seas, it's slow, it's risky, and it could potentially disrupt the entire operation.
Yeah, I can imagine. The developers must have had some major headaches trying to navigate that massive code base. So Berger-Levrault, they decided to take the plunge and migrate Homage to this microservices architecture. How do they actually use that model-driven approach that we talked about?
Well, they started by extracting a model from Homage's source code, essentially creating that detailed blueprint of the entire system.
So they captured all the nooks and crannies of that cruise ship in their model.
Precisely. And then they applied that identification approach we discussed, the one that leverages the existing internal architecture to pinpoint the best places to carve up that monolith into those microservices.
So they use that blueprint to carefully mark where to make those cuts, making sure that each section could function as its own independent unit. How many microservices did they actually end up with?
They ended up with 4 distinct microservices, each one responsible for a specific part of the license management system. Imagine dividing that large cruise ship into 4 smaller, more specialized vessels. One might handle customer accounts. Another might manage license generation. One could track usage. And the last one could be dedicated to reporting and analytics.
So instead of one massive ship trying to do it all, we now have this fleet of smaller, more agile boats,
Yeah.
each one optimized for a specific task. But how do they actually make those cuts? Remember all those dependencies between classes that we talked about? How do they make sure everything still worked correctly after they split up the monolith?
Well, that's where those transformation patterns we mentioned come in. The researchers, they meticulously applied these patterns to refactor the code, break those dependencies between classes that now lived in separate microservices, and establish new ways for those services to communicate with each other.
So it's like they install these new communication systems on those speedboats, allowing them to coordinate and share information seamlessly. It sounds like a pretty complex process, but it's fascinating to see how they tackled it step by step.
And remember, this was a real-world application, not just a theoretical experiment. And the thesis honestly points out that there were practical challenges and adjustments that were needed along the way.
Oh, of course. In the real world, it's never as smooth sailing as it seems on paper. There are always unexpected waves and obstacles to navigate. What were some of those real-world considerations that they had to address?
Well, for example, they had to figure out how to deploy those microservices, how to manage communication between them effectively, and how to ensure data consistency across the entire system. It's like launching those speedboats. Without proper navigation equipment or communication protocols, it could lead to chaos.
Oh, absolutely. It's one thing to build those individual boats, but it's another thing entirely to make sure they can sail together as a cohesive fleet. Did the thesis go into detail about how they tackled these deployment and management challenges?
Yes, it does. It discusses the specific technologies and strategies they used to deploy and manage those microservices, providing some really valuable insights for anyone considering a similar migration.
That's really helpful. It's great to see the theory put into practice and understand the nitty-gritty details of how they made it all work. But the big question is, did this migration actually improve things? Did those microservices deliver on their promise of greater agility, scalability, and efficiency?
That is the million-dollar question. And to answer it, the thesis presents a pretty comprehensive evaluation of Homage's performance before and after the migration. They looked at things like response times for user requests, the time it took to build and deploy the application, and the overall resource utilization.
So did those speedboats actually prove to be faster and more fuel efficient than that old cruise ship? What did the results show?
The findings were quite revealing. While migrating to microservices did introduce some overhead, mainly because of that additional communication required between those independent services, the overall benefits were significant.
Okay, I'm on the edge of my seat here. Break down those benefits for us. What kind of improvements did they see?
Well, one key area was build times. Compiling and deploying those individual microservices was much faster than building the entire monolithic application. Developers could now focus on specific services, and they didn't have to recompile the whole thing every time they made a change. It's like being able to upgrade the engine on one speedboat without having to dry dock the entire fleet.
That's a huge time saver for developers. Faster build times mean they can churn out new features and updates much more quickly. What about the user experience? Did those microservices improve response times for users?
Interestingly enough, from the user's perspective, the difference in response times was almost negligible. While there was a tiny increase in the time it took to process requests, it was so small that users wouldn't even notice it.
So no noticeable lag for users, which is great, and faster build times for developers. It sounds like a win-win situation. Were there any other interesting observations from the Homage migration that you think our listeners should know about?
One key takeaway is planning and configuration are absolutely crucial. During this whole migration process, you know it's not enough to just chop up the monolith. You really need to think carefully about how those microservices will interact, how they'll be deployed and managed, and how to ensure data consistency across the entire system.
It's like planning those speedboat routes, establishing communication protocols, and making sure each vessel has the necessary supplies and navigation tools.
Exactly. And the thesis emphasizes the importance of iterative development, testing, and continuous improvement. Throughout this entire process, you know it's not a one-and-done deal. You need to be ready to adapt, learn, and refine the system as you go.
So it's about embracing that journey of continuous improvement, which is something we always emphasize here in the deep dive. This Homage case study really brings those concepts to life and shows us that migrating from a monolithic architecture to a microservices architecture can bring some pretty tangible benefits.
It does. But while the Homage case study showcases the potential of microservices, the thesis also acknowledges that monoliths aren't going extinct anytime soon.
That's a great point. It's not about blindly jumping on the microservices bandwagon. It's about understanding the trade-offs and choosing the right architecture for the right situation. So let's delve into that a bit more. When does it actually make sense to stick with that monolithic approach?
Yeah.
And when do those microservices speedboats really shine?
Well, the thesis lays out a few key things to consider. One is the size and complexity of the application. If you're dealing with a smaller, more straightforward application, the overhead of moving to microservices might not be worth it. It's like,
Yeah.
using a speedboat to cross a small pond, you could probably just walk there faster.
You don't need all that extra machinery. For a simple task, what about the team's expertise? Does that play a role in the decision?
Absolutely. Managing a distributed system of microservices demands a totally different set of skills compared to maintaining a monolithic application. It's like having a crew that's trained to sail a single ship. They'll need additional training to handle a whole fleet of smaller boats, each with its own quirks and requirements.
So it's not just about the technology itself. It's also about having the right people and processes in place to support that shift. Makes sense. Are there any other factors companies should consider?
The thesis really emphasizes aligning the architecture with the business goals and needs. If the business requires rapid development cycles, independent scaling of features, the ability to quickly adapt to changing market demands, then microservices can be a real game changer. It's like having a fleet of speedboats ready to deploy for different types of excursions, each catering to specific passenger preferences.
But if those needs aren't there, then sticking with that trusty old cruise ship might be the more pragmatic approach. It's not about chasing the latest tech trends. It's about making informed decisions that truly support the business objectives. And that's a really valuable takeaway for our listeners.
What I found particularly interesting about this thesis is its emphasis on model-driven engineering. Seems like a really powerful approach to managing the complexity of software development, especially as we move towards these more distributed architectures.
Yeah, I agree. Model-driven engineering can be incredibly beneficial, especially when you're talking about microservices. Because by using models to represent the system, you can reason about the architecture at a much higher level of abstraction, which makes it way easier to identify potential microservices, analyze dependencies, and plan that entire migration process. It's like having a set of Lego blocks for your application. You can easily assemble and rearrange those blocks, which are the models, to create different structures, which are your microservices. Experiment with different configurations, see how everything fits together before you commit to a specific design.
That's a great analogy. And the beauty of MDE is you can automate a lot of those tedious tasks. All that error-prone stuff involved in code generation and transformation. This frees up developers to focus on the more creative and strategic aspects of software development.
So instead of getting bogged down in all those low-level details of coding, developers can spend more time thinking about the big picture, the overall architecture, how to best meet the needs of the business. That sounds like a much more enjoyable and productive way to work.
Absolutely. And as software systems continue to grow in complexity, I think MDE is going to become even more essential. It gives us a way to manage that complexity, enhance reusability, and just make more informed decisions.
About our software architecture, well, that brings us to the end of our deep dive into the world of migrating monolithic applications to microservices. We've explored the challenges, the solutions, the real-world implications of this whole architectural shift. And we've also seen how model-driven engineering can play a key role in making this transition smoother and more efficient. So before we wrap up, what are some key takeaways that you hope our listeners will walk away with from this deep dive?
I think the most important takeaway is there is no silver bullet when it comes to software architecture. Monoliths have their place, and so do microservices. The key is to understand the strengths and weaknesses of each approach and to choose the right architecture for the specific needs of the project and the business.
Absolutely. It's about making informed decisions based on a clear understanding of the trade-offs. And this deep dive has hopefully equipped our listeners with the knowledge and insights they need to make those decisions.
I hope so. And I encourage everyone to keep learning and exploring new approaches. The field of software architecture is constantly evolving. There's always something new to discover.
Well said. A huge thanks to you for joining us on the deep dive and for sharing your expertise.
It's been my pleasure.
And to all our listeners out there, thank you for tuning in. We'll be back soon with another deep dive into a fascinating topic. Until then, keep exploring, keep learning, and keep diving deep